Hello. We're gonna explain how a pressure compensated control works on a variable displacement pump. Video done by Edgar Lindo. Info at tu.biz, www.wtu.biz. Okay. So how does the pressure compensated control works? What we have over here is a variable displacement pump. Over here we have the suction line, and over here we have the pressure line for the pump. These lines over here, these are sensing lines. One line goes to one cylinder. Cylinder extend. This cylinder over here, it also has a spring that pushes the mechanism, push the mechanism to open or close the pumping action of the pump. And so under normal condition, the pump has not set a pressure compensated. Let's say this is very low or minimum. The pump is open, the mechanism is open, the pump is taking oil from the suction line and putting it out through the pressure, and it goes out to the system. So let's say for this particular example, we want to set the pump at 3000 psi. Set the pressure compensated at 3000 psi. So how do we do that? Through the pressure line over here, there's also a sensing line going to the pressure compensated valve. Over here, we have there is a screw with a spring. When you tie the screw in, when you push the screw in, it gives more force to the spring to push the valve in this direction. Keep the valve, let's say, keep the valve open and keep it in this direction. While pressure is being built over here on the pressure line, let's say we want this at 3000 psi, right? So we put the screw in, give more force to the spring, and pressure is building on this side. Let's say you have a cylinder, the cylinder extend all the way in. There's no more room for the oil to go anywhere. So pressure start building up. Pressure start pushing in this sensing line, start pushing against the spring and against the screw that you have, and it pushes, but it cannot open yet, because let's say you put it all the way in, or you put it in enough to build the 3000 psi. In order for you to see this pressure over here, you would have a pressure gauge where you can read the pressure. And the more that you screw it in, the more resistance you give it. So once it reaches the 3000 psi that you want it by reading the gauge, then it has enough force to start pushing the valve in the other direction, which is overcoming the force of the spring and the screw that you have on this side. And when it overcomes the force of this screw, now you have this is the force of the pressure pushing in, and there's also a sensing line over here that comes through this port. And once the valve shifts, now you have fluid going to this cylinder over here that is also connected to the mechanism that opens and closes the pumping function of the pump. And now you have 3000 psi coming in this side. There's 3000 psi pushing in this direction, and now you have also 3000 psi coming through here into this cylinder, pushing in the opposite direction. Now this cylinder over here is bigger. It has more area than this cylinder in this side. So when you have more area and the same pressure, 3000 psi on both sides, the bigger cylinder can create more force. With more force on this side of the pump, it forces the pumping mechanism of the pump to be closed. So it reduces the displacement of the pump. The displacement of the pump comes to 0, and you close it all the way out. Why? Because you have this cylinder extended over here. It closes the mechanism. Now during that time, the pump is still running, it's still rotating, and it's still taking oil from the suction line, but it's not able to put it out on the pressure line. It's only recirculating inside the pump, and some of it going to the drainage, going to the drain line. Now, in this at this moment, the system, it maintains pressure. It maintains pressure on the pressure line. It keeps the valve shifted, and it keeps pressure against the cylinder, which closes the mechanism. Now, once the pressure is released on this side, let's say there's another movement, the cylinder is now retracting, or you go to the next phase in the hydraulic system, which lowers the pressure to less than the 3000 psi, of the max pressure that we want it to work. At that moment, you lower the pressure on the pressure line, and the spring and the screw that you have on this side of the valve, it once again retake control of the valve, and it pushes the valve forward in this direction, and it closes, opens or closes, whatever way that you want to see it, but it pushes the valve in this direction again, and what it does is the oil that was coming from the pressure line going to the cylinder is shut off again. So it's closed again, and the valve is maintaining it closed because the pressure is less than the 3000 psi, and so there's more force going in this direction of the valve, keeps the valve shut, and now you have no more pressure going into the cylinder. And when you alleviate the pressure on the cylinder, this other cylinder over here is still pushing. You know, there's still coming pressure into this cylinder. So this cylinder, it extends again, and it opens up the mechanism for the pump to take oil from the suction line and put it back into the system. So at that moment, at the same time, these lines that you see over here, these are just draining lines, just oil, internal oil going back to the reservoir. But at that moment, you have now a pressure compensated control that is closed once again. So, and this is how a pressure compensated control works on a variable displacement hydraulic pump. Some manufacturers, they may draw it differently. They may have different drawing ways, but the concept is pretty much the same. As you have some resistance going through a valve that allows pressure coming in and shift the mechanism, and then when that pressure lowers, then it closes it back again, and that is how you achieve a pressure compensated control. Now, why do people want to have a pressure compensated control? A pressure compensated control, what it does, it maintains pressure in the system, but it does not pump oil into the system. What that means is that you are saving some horsepowers, and that you are also preventing heat buildups in the system. If you wouldn't have a pressure compensated control, the other options is a fixed displacement pump, in which the pump pumps oil all the time, and a maximum pressure. What it does is you have a relief valve on the side, and once it reaches the maximum pressure, the relief valves open, but the pump, it keeps pumping, and it keeps dumping oil through the relief valve, which creates heat in the system. So a pressure compensated pump it saves the system for overheating, for creating that heat under maximum pressure condition, and it also saves some horsepower. So anyway, this is the pressure compensated control. Thank you for your attention, and we'll see you next time. Bye bye.